I was a post-depression baby on the tail end of the depression. So I always thought of things as black and white. There was no color TV, no internet, no telephone. That's why I don't like that color blue, 'cause it reminds me of a life that I once knew, that color blue. Mining for gold till I was much too old, wasting my life, losing my soul. The shadow in my life, it's taking its toll. That's why I don't like that color blue, 'cause it reminds me of a life that I once knew, that color blue. Country music's alright, but I'm more rock and roll. Yeah, I'm more rock and roll. Landed on my feet, had holes in my soles. Blisters on my toes, but I won't call Dr. Scholl's. That's why I don't like that color blue, 'cause it reminds me of a life that I once knew, That's why I don't like that color blue, 'cause it reminds me of a life that I once knew, 'Cause it's all in the fight, that's a fight I won't lose. I won't wear no white shirts or blue suede shoes. I'm walking down this road, but I'm not singing the blues. That's why I don't like that color blue, 'cause it reminds me of a life that I once knew, That's why I don't like that color blue,
That was 3 fucking minutes long. What the hell were you thinking, Andrew?
Well, actually, I had one that was 6 minutes long, but I didn't think that was appropriate.
Right, ladies and gentlemen,
Yeah.
Mr. Conway Twitty.
Mr. Conway Twitty. Or in the retrospect of Andrew, Mr. Red Sovine.
There we go.
So that's what the intro should be. The intro should always be Red Sovine.
Well, we did do it for Christmas, so.
See, look at this, man. We had a bunch of people come in, and then your damn intro bored them out of their mind, and they were blue. They were blue.
Yeah, I figured they would be enthralled and just have gone over to that guy's channel instead.
They probably did.
Probably to hear more of these songs.
Yeah, they probably actually. That's what you did, Andrew. Instead of getting people to come to us,
either that or
you ended up
you can get to hear Bitcoin, baby.
Pushing a why, yeah.
So, but why are you blue?
I mean, I don't like that color blue.
Why don't you like the color blue?
Because it reminds me of life that I once knew.
Because it reminds me of them crab niggas, baby.
Suppose so.
I was a pirate once.
See, I'm a science fiction nerd about it, so I'm rereading the Hyperion Cantos right now. If you guys ever read it,
No.
great.
I have not.
So I'm at this part in the fourth book where the main character gets a kidney stone as he's trying to save the day, and instead has to be helped by this group of people on this planet called the Amulet Spectrum Helix, and he gets saved by one of the families that dresses in blue, which to them symbolizes intellect and caring.
That reminds me of a that reminds me of a script story that I wrote when I was in high school. It was I did a play on of the Raiders of the Lost Ark, except for I made it instead of the Ark of the Covenant. It was a diamond. It was a crystal that came off the Ark, and it was about a thief who gets into it with a former FBI agent turned black market like syndicate leader.
That's pretty
his name was Asshole McGraw. General Asshole McGraw was and
I'm sure your lit teachers loved that.
I didn't. I know it was for me and my friends.
Anybody. That was just for
I think we shared the same English lit teacher. I think she would have kicked his ass.
I had a
this was when I was at Bacon, so I would. Yeah. I wrote this when I was at Bacon, not Lawrenceburg. So the things that were in it were kind of quite not
eccentric.
Really good for. Yeah, it was very eccentric. So it probably wouldn't have been for the ears of people at a Catholic school.
Oh, okay.
Actually, if you're talking about a Catholic school, probably the question is
let's just put it this way. There was some sexualized aspects in there where we went to Egypt and there was a lot of hookers.
Shit.
That's awesome.
I guess it's better than being an economist in Egypt.
Yeah, but I guess
I actually published
that's a little inside baseball
to my classmates. It was called The Midget, and in every strip, by the end of the sixth frame, the midget had basically either been brutally dismembered by something, blown up along with half the planet, or squished by a very large woman.
I did another one. This was when I was in my sophomore year. So now I'm in Lawrenceburg now, Andrew, and a friend of mine whose name was Zach. Actually, he actually had wrote a story a long time ago, back when he was like in middle school, and he finally like printed it all out for everybody to read it. And I liked it so much. I'm like, I'm gonna extend it and make it, and then make another story out of it. And I kind of like stole a lot of it. I got the inspiration, and it sounded like if you read the beginning, it was kind of stealing, but it ended up turning into a whole different story. And everybody was pissed because I'm like, you stole this stuff. I'm like, why don't you read the whole story? And it was based in Tokugawa, Japan, around the his story was, and I extended it to emulate another character that I implemented called Mirko, which I have no clue which has no meaning. His main character was Masume was the main character, and I just unfolded it into like a 19th century. Like I had different themes within it. I took elements of what his story presented with my own twist, and then I had just watched The Last Samurai too. So I implemented The Last Samurai into it to make it into an interesting tweet. Yeah,
sticky fingers.
They're only like 5. They're only like, how many stories did Shakespeare discover different tropes for? And they're all pretty much covered. Like all you have to do is copy Shakespeare and change the names to protect the innocent, mix and match the parts, and you've got yourself a story. But you can't write one that doesn't fit into those because they don't. Exist. There's a limited number of story shapes.
Right. Well, that's how the universe is pretty much created. Like
exactly.
The fact is like you're gonna have to gain inspiration from somebody else anyway. So when you're gaining inspiration from someone else, you're gonna implement some of what they brought. So like we were talking about copyright and at one point, right? Maybe it was a couple weeks back. Not necessarily copyright, actually, more like patent, but copyright ties into it.
Yeah.
What is the point of what is the point of that anyways, of trying to
Right.
implement structures like that when in reality we're all taking from each other anyways? That's
Oh
how the
yeah.
best
No.
ideas come about.
All art feeds off of the art from before, just like all sciences stood on the
Mhm.
shoulders of giants, right?
Mhm.
We wouldn't be talking about chronotopology at all if it weren't for like, you know, probably at least 600 or 700 known contributors and the thousands to tens of thousands to even hundreds of thousands of people that supported their work, right? Like
Mhm.
everything that we're doing is complementary to what came before. We used to call that inspiration rather than stealing,
Yeah.
you know?
And
The
then
millions of the scientist fans.
Yeah.
see, Andrew likes to steal from WWE all the time. You better be careful, dude. They will sue you. You just
I
say
know.
one thing. One thing, and they'll just be like, what? Next thing you know, you're in bankruptcy.
It's pretty silly too, because
Right.
they could just take the compliment of being a source of inspiration for someone else's creative work and also take the free advertising.
You would think that, but it's WWE.
That's
Right?
the
No,
cost of
exactly.
prestige.
There are two
If it's not-
philosophies towards protecting creative work. One says you only need to protect creative work if you're uncreative and thus don't have any new ideas to work on. And then the other one says that it's an asset and people will only create if nobody else is allowed to copy them.
And this is what I tell WWE: you haven't been creative in about 3 years. Get over yourselves. And even that was not very creative.
Yeah. Here's an idea, guys. Maybe you try changing the shape of the ring.
Let's make it a six-sided ring like TNA again. Let's bring that back. I heard wrestlers actually didn't like that. All the TNA superstars, they loved it when TNA decided to go traditional and go back to the four square ring.
Yeah.
Because it's just easier to work with.
They could also make the ropes uncertain, right? Like there could always be one side that was loose enough that you could throw somebody through and you'd never know before the match or something like that. That'd be pretty fun.
Yeah, they could, but then safety. Everything's about safety now.
It is really. I mean that has always been absurdly about safety. Most people don't know that, but they care deeply about making sure that nobody gets hurt.
What they really need to do is they just need to do. Remember the final match in Ready to Rumble, Andrew. You definitely know. But yeah, that's what they need to do. They need to do a wrestling promotion that's themed around that, and the ring is just that three-tier
different
cage.
stars.
Yeah, they should just do
I think
that.
that'd be a cool match.
That would be an interesting theme. It's just sort of like how in the independent circuit you have like, what was it? You've had a number of them, but what was the real one that was kind of like it put ECW to shame? Like CZW, it was Extreme Rules, like the whole entire that was their niche, was literally everything was hardcore and anything goes. But you don't do that. Don't be stupid. You control it, but then put it in a 3-tier cage.
And
cool. That's your ring. Every match in a 3-tier cage, and you don't know what to expect.
I watched.
You could also do a black tie event and make all of the competitors wear suits.
I mean, they do that when they go. They already do that
during the match.
They already do stuff like that when they go to Riyadh. When they go do their events in Saudi Arabia, the women can't. They actually have to cover up. Oh yeah, which is kind of silly because like when you're in that ring, you kind of want aerodynamics. So that's one reason why they all pretty much are half naked, women and men alike.
Right.
But at the same time,
dangerous.
Yeah, but because they're in Saudi Arabia, the women have to cover up because of Sharia. So they have to cover all the women up. It's like what? Okay.
That's from, as I understand it, from one of my Muslim friends, that is actually an over exaggeration of Sharia because it doesn't apply to non-Muslims. They just have a way of
Mm.
addressing
Wow.
non-Muslims in Riyadh that's a little bit aggressive, but it doesn't have to be
Mm.
into their doctrine. They could be chill about it, but they're just not.
Yeah. Also, we have a comment from Catherine Van. I don't want to butcher your name, but this is to you, Greg.
Sorry.
I don't know. Let's lead off into that one. What's with the standard of vaping?
So I'm all about liberty. Number one way
Novelty,
to get me to do
friends,
something is
novelty.
tell me not to. In fact, seriously, the number one way to get me to do something is to insist I don't.
Vices are not
I
crimes.
do
It's
appreciate
7
your
weeks.
concern, though. It was very kind of
Yeah.
you to express concern for a fellow human being.
Yeah, the fact is like that's people are gonna do what people are gonna do, even if vaping might give you pneumonia.
You know, interesting story. If it were not for these, I would probably be dead already because I used to smoke cigarettes, and I have terrible asthma that this does not trigger. Right? I actually can breathe and talk like normal. So whether or not it's all the way good for you, it's certainly better for me than the alternative.
Well,
So I used to
it's
go
certainly, you know,
200 shot inhaler in a month when I was smoking still, and I haven't gotten a new one of those in over a year now. So
the ecosystem survived. I remember before COVID, there was this thing about vape pens, and they think that was they said that it was poisoning people with vape pens, but it was just COVID. But that nobody recognized the connection.
yeah, well, I mean, there was also the THC ones that were completely unregulated.
Yeah,
people were pouring a particular. Well, every vape, in order to make that mist, has to have an additive, and that additive is usually vegetable glycerin if you're doing it the healthy way. But in order to get the consistency they wanted for the THC, which is stickier, they had to add something else that was actually causing serious permanent lung injuries. So that was an example probably of what happens when you outlaw a thing as opposed to when you're permissive with it. Because if you looked at the tobacco-based vapes or the nicotine-based vapes, they didn't have any of that stuff in there.
Unintended consequences.
Yep.
You bring the hammer down, you're gonna have a trade-off, and it's not for the better.
That is it's all about trade-offs. That's what it is. Like you see the outlaw, the prohibition, and obviously that doesn't work in order to hinder people from doing things, because we all have a rebellious spirit. But at the same time, when you go full-fledged and try to bring about something and make it legal, that in itself has a dramatic effect in a trade-off, because you end up doing, instead of gradually implicating something into the legal process, like take marijuana, for example. We've kind of like did a turnover, like most of the states, domino effect, basically defied federal law and brought about this new market, when in reality, and it caused an uproar of just a domino effect, and you're starting to see this big industry, and the over-regulated aspect ends up coming into store, and then you have the corporate lobbying that just fixes a market niche that isn't to the benefit of anybody but big business, really. So when it comes to outlawing, and when it comes to making things legalizing, there has to be a balance. And that's there has to be a balance, because you can't outright prohibit something. That's going to have consequences, but you can't outright legalize something, and without understanding the effects.
Here's the trick, though. Maybe the choice is more stark than that, right? maybe there's a lot of stuff we'd like to regulate and a lot of stuff we'd like to control, but given the band limit on possible communication that can happen from government agencies to human beings that are governed, you run into an impossibility boundary, right? Like a literally in the physical world, a limit on how much stuff you can communicate broadly and get reactions from that are timely and expected as the response is designed, right? Like you design a regulatory program and you put it in place and it works. Designing another one like that and sticking it right next to it in the same channel might actually make both of them work more poorly. And eventually, if you keep adding, you get to the point where none of it does anything, even though everybody spends a lot of their time trying to obey it. It ends up forcing workarounds, and those workarounds are essentially what causes the system to create the problems that it tries to stop.
Well, there's two ways that you can go with the law. It's confluence. You fully embrace the law. Everyone falls in line. And eventually it's just so stiff that it can't sustain itself, or divergence where there are certain people who take an opportunity, take a chance, and some of them get away with whatever that they're breaking the law. Some of them don't. But eventually you've arrested so many people you can't afford to maintain, keeping them in jail, and the system collapses from that perspective. So the law is never
break the law.
Cascading failures across the whole system start to happen when you're over communicating.
Welcome, Lisa. Thank you.
Yes.
That's not even really a moral argument so much as just a physics argument, right? Like it's just
right.
There's only so much that we can do with long distance coordination. Before the very channel that carries it in reality starts to smear and become insensible to us.
You want to know how you get a copyright strike? Break the law, break the law, break the law, break the law, break the law. Oh, we just got a copyright. Thank you. Yeah, I just got us a copyright strike because of 3-6 Mafia. What gangsters, man? They.
I think that was fair use.
All right, I'm out of here. See ya.
It is fair use, but DJ Paul's a rat.
Too much fun.
So what are we talking about today?
We are on a number 3, right? Is that where we're at?
I believe so.
We are on
I got it pulled up here.
Number 3. And let's just put it that before you bring it up, the fact of the matter is, and I both summarized this, read it, and listened to it, and tried to ascertain it myself. And I think paper 3 and inevitably paper 4, so this is kind of a sneak peek. It goes with the title of this. I really do think that the math at this point is leading to God.
Okay.
Rebuts, Andrew?
Well, I'm interested to hear why you think that. I don't have any particular rebuttal yet.
Maybe we should
I think
everybody see if they can spot it.
Yeah.
I think
I'm going in fresh.
I think Zach's got a good sense of where the physics and the faith overlap.
Okay.
Yeah, that's a thing. The fact is when I read this, and then I let both Copilot and GPT summarize it a little bit too, and I've rigged them to be philosophically astute. So I kind of garnered through my own thoughts, my own thought process, and then had the tools check it, and it really does. It comes about to this idea that the physical really does transcend into a metaphysical. And I think that's what we're missing in today's day and age is we've become so comfortable in our technological advancement through society and in this digital age and this excessive information age that we are losing the metaphysical touch. And I think
But
if we look
metaphysics
through the lens,
have not always been
mm,
a dirty word, right? Like
mm-hmm,
in the institutional science we have today, to call something metaphysics is to say that it's not empirically verifiable in any meaningful way. Therefore, you can have all the opinions you want about it, but nobody can confirm them by looking at something that you don't control, right? You have
mm-hmm.
to accept your take on metaphysics as one take on metaphysics, and that is the compellingness of a metaphysical argument has to do with its emotional resonance. It's not something that you can math out. And the cool thing about the math in chronotopology is the places where the math refuses to speak is exactly where it makes room for a productive metaphysics that doesn't have to be a dirty word.
Here's a question for you, Greg. Is
Yeah.
it, Lisa asks, is it the current math or a system that has been hidden from us? And why was ether removed from the periodic table?
So the current math and the current system are not so much hidden from us as they are completely incommensurable in an explanatory way, right? Like metaphysics is now what the scientific community smears attempts to make explanatory meaning of results, right? If you try to explain how all of this fits into the big picture in a narrative fashion, where you're trying to tell a story that makes sense given what we've seen, they're immediately going to just say that's metaphysics, right?
Mm-hmm.
But in reality, having a sensate story that people can think inside of that maps to the physics is key to making them any kind of useful at all, whether that's in strengthening your faith or strengthening your engineering project, right?
Mm-hmm.
And it has to do with steeling human will up to do what it believes it should do, right? An individual will decide a lot based on how they feel about the big picture. And that's informed by metaphysics, right? So we can't ignore any semantics if we're going to go with chronotopology, right? Because words, ideas, concepts, those aren't floating things that just sit disconnected above actual physical reality. They connect to it, and they connect to it potentially meaningfully if we find the right way to seek it. And for a long time, shut up and calculate became the buzzword of serious science. And that has to stop if we are going to make sense of any of the math. We didn't really actually change much of the math with chronotopology. We added corrections, right? But a lot of what made chronotopology seem like a compelling research thread for me was that the more that I dug into it, the more that it started to surface the math that we already know in slightly modified forms, but within a coherent, explainable framework. Like you don't reinvent relativity and the math equations that the general and special relativity came up with, right? We don't scrap those and throw them out and say they're wrong. We fit them into the bigger picture. They tell part of the story, right? And they do need a couple mathematical modifications because what people have misperceived as uncertainty equals chaos is actually more of a misunderstanding about the band limit of the universe. And the chronotopological correction in almost all cases has to do with making the equation eliminate infinite detail from its purview, right? It constrains it. It's more like a filter or a cutting rule that we apply to all of these equations when we correct them chronotopologically. So all of the math that we've been discovering, science works well, right? The existing science work well. It's just the culture of it has become toxic in a way. And I think that's what, Lisa, you're noticing, like the way that they're framing things has a lot to do with maintaining status and less to do with helping people use what we understand about the world to make it better to live in.
Now, I just have a question for you, Greg. This may be unrelated, but I just remember growing up, being told back in the 1950s, maybe it's not to this level, but that there was a reform in the way that math was calculated, at least in Indiana. Do you know anything about that? Is that related to that at all? Or
Are you talking about the new math era?
I
Yeah,
believe so, yes.
that was a
Common
really cool
Core.
program that would have made my life so much better had it been adopted in the 90s instead of the 50s. I still
Rather than
lament
Common
the
Core.
loss of the new math. The new math
Right.
had 3 problems with it and 1 glowing benefit that made it worth the time, worth the trouble. The 3 problems were: it was hard to grade objectively, it was hard to explain to parents, and it was hard to find
Years.
qualified teachers. Because what the idea of new math was is, what if we've been teaching math backwards? What if arithmetic is the last thing you need and the first thing you need is set theory? Right? What if you start teaching kids theory math instead of arithmetic as a starting point? Right? The arithmetic becomes necessary later if you engage them. And if you engage them with these really complex, beautiful ideas, the most fun parts of math are the theory at the top, not the arithmetic at the bottom. Right? If you want kids to engage with it, talk to them about, all of the different crazy mathematical demons that people invented, like Laplace, where you try to calculate the future history of a world from this idea that if you knew everything about the current state of a system and all of its mathematical rules for how it evolves, you could calculate it to the end perfectly, if you knew the exact state. Or like sort of the quantifiability of movement, so where you can mathematically imagine dividing something in half over and over again and never reaching the number, right? Like, you've seen that old elephant thing where you take an elephant and you get a smaller elephant and a smaller one, and mathematically you will never get to the edge of the page, right? But physically, you know that you can't do that infinitely. So there's this weird disconnect there. Those are the kinds of experiments that they would teach kids to think about in the new math. They'd start with theory at the high end and move down the ladder instead of up.
I had a grandparent.
It was really good.
I had a grandparent that tried to teach me that, and it stuck for a little bit, but then I finished the class and stuff like that. So I just figured I'd ask because I remember that.
I wish to this day I'd had the opportunity, because I probably would have ended up as a mathematician very early on instead of thinking for like 20 years that math just wasn't my thing.
I think in set theory,
turns out I just make a shitty adding machine.
I think the difference between like the set theory can explain certain aspects of the universe, and geometry can extend out into the transcendental aspect of metaphysics. We just don't necessarily know that because we start literally on the lowest end from when we're younger, and we just focus on the basics of arithmetic. And I really do think that math can, I think, well, the way that society has become, I think we really are in a fight for our lives within the physical realm, in a spiritual warfare on the basis of our free will. As Aaron Day would correctly ascertain in his own way, we are actually trying to figure out how do we navigate this world and establishing what our will is individually, collectively, as a human species. So, and I think the math can actually coordinate that, but we have to go the right way. We have to go the correct direction with that math in order to explain everything around us, rather than focus on the basics.
Well, and you know how we can do that with math. You know what math is for, right? This is one of the neat things about chronotopology, is you get explanations about why things, as opposed to just how things, right? So why math? What does it do? What's the point? What's its purpose, right? Ultimately, it is a symbolic language that gets us as close to possible of the edge of human distinguishability as you can get as a human, right? Math is the language at which we express the very edge of what we can distinguish.
That's pretty insane.
And that's all. That's its purpose. It's a way to communicate the very borders of distinguishability, the parts of the universe that we can understand as distinct from something else, and the parts that we can't even perceive because they're outside of our realm of perception. right? The actual continuation width, we will never know. The compressed one that we can see from our worldview is the one that math is able to describe at the very edge, and that's the only one that can get that precise. So that's what math is for. It's to describe a new distinguishability space that we had never perceived before. It's a way to find and open broader futures.
That is pretty intense stuff.
Well, let's dive in to a rabbit hole.
All right,
Sounds good.
here we go.
Paper 3, a spoken word guide, log drift dynamics, avalanche structure, and regime transitions in continuation geometry. Part 1, what this paper does. Paper 2 gave us a stable coordination constant. Paper 3 asks, what does a live regime actually do over time? Not in mythic language, not in vague complexity jargon, not by pretending avalanches are just random explosions. It asks, if a synchronized regime grows under admissible continuation, and if closure keeps pressing back against that growth, what dynamical law falls out? The answer is elegant. Growth is not arbitrary. It becomes a drift process in log space. And what look like sudden stochastic collapses turn out to be lawful regime transitions. That is the paper. Part 2, the starting point. The paper begins with a synchronized subcauset whose size changes over time. This is a live, local regime, not a frozen object, not a static graph, a structure that grows. Paper 2 already gave us the coordination constant and the fluctuation law. Paper 3 now turns that into dynamics. The first thing it does is separate the growth into two parts, a regular component and a fluctuation component. That distinction matters because it shows that the regime is not perfectly smooth. There is drift, there is noise, there is coordination tendency, there is residual fluctuation. All of that has to be carried together. Part 3, mean field growth. Now the paper writes down the mean field law. This is one of the key moves in the entire early canon. Growth is not simply proportional to size. It is checked by a logarithmic suppression term. That means the regime is not being modeled as unconstrained exponential expansion. It is being modeled as expansion under closure pressure. This is exactly the same duality already hinted at in paper 2. Forward continuation tries to multiply. Closure pushes back logarithmically. That is the balance. And the paper says something subtle and important. The stabilizing term is not linear in raw size. It is linear in the logarithm of size. That means the system is stabilizing in log space, not in naive counting space. That is one of the main insights of the paper. Part 4, why the logarithm changes everything. Once the logarithm of regime size is taken as the active variable, the dynamics simplify dramatically. What had looked non-linear in raw growth becomes linear drift in log space. This is not a mathematical trick. It is telling you something real about the regime. The live system does not experience stabilization by directly pinning an integer count. It stabilizes by balancing multiplicative continuation pressure against logarithmic closure enforcement. That is why the paper says the true equilibrium exists in log space. This is a major correction, because many systems that look unstable in ordinary coordinates are actually perfectly well behaved once the correct variable is chosen. Paper 3 identifies that variable. Part 5. The Ornstein-Uhlenbeck result. Once the dynamics are written in log space, the paper shows that the regime obeys a classic drift and noise process. This matters because it means the system has a preferred equilibrium, a restoring tendency back toward it, and universal noise around it. In plain language, the regime wanders, but not aimlessly. It fluctuates, but around a lawful center. It is constantly perturbed, but those perturbations are not the whole story. The closure slope pulls the system back. This makes the regime a breathing object, not a rigid one. Alive, not static. Part 6. Forward expansion and closure enforcement. Paper 3 then makes explicit what was structurally implicit before. There are two pressures: forward expansion, closure enforcement. Forward expansion acts multiplicatively. That means it scales with the regime's size. Closure enforcement acts logarithmically. That means it scales with the logarithm of regime size. This is the same duality already seen in paper 2, but now made dynamical. The paper says, in effect, expansion wants more continuation. Closure insists on admissibility, and the actual regime is the projection of their difference. That is very clean, and it means the constant from paper 2 is now no longer merely descriptive. It becomes the slope of logarithmic suppression in live dynamics. Part 7. Equilibrium is real, but it is not perfect. The regime has an equilibrium. That much is clear. But equilibrium here does not mean stillness. It does not mean static perfection. It does not mean exact fit. It means the drift balances in log space. So the system hovers around a preferred regime size. Fluctuations remain. Residuals remain. Noise remains. This is important because it means stability is not silence. It is structured wandering inside an admissible basin. That is a much more realistic picture of persistence. Part 8. Plateau structure. Now the paper introduces the plateau. A plateau is a regime where the continuation width is no longer increasing in any meaningful way. Inside the plateau,
Okay,
fluctuations
let's
are
pause right here.
in log space.
Okay.
The
Something worth talking about plateaus just briefly before we jump into this idea, and basins in general. So
Sure.
stability regions in the system can be represented on sort of like a topography, a manifold that looks like ground if you project it. Like it looks like literal physical land, right? So picture like hills and valleys and plateaus physically, actually, right? That's not what we're talking about very specifically. We're actually talking about the processes that formed those things, but but they exist in our subjective experience too, right? A plateau for us is everyday life without anything new happening to us, right? A stable basin that we can wander in is sort of like all of the places that we go normally, right? Like you go to work or you go home, you hang out with your family, you go in the swimming pool you always go to, you eat at the restaurant you like. Those are the places that you wander within your stability basin. That is your plateau, because it's not changing in any meaningful way in terms of new stuff happening. You are working within a space that you're already comfortable. That's a really great way to simplify the idea of plateaus, because when we talk about lift, we're going to be talking about what happens when all of the possibilities within your stable plateau are exhausted, right? And the system, then whatever system we're talking about, has to do something in order to continue that changes things. And that's sort of where this is headed. So I thought that was worth giving a much more down to earth, grounded way to think about it before we let it charge forward.
I think you should explain a little bit what do you mean by lift?
When the video gets to it, lift is, so essentially, if you think about, and we're going to bring up avalanches too, because a lift event is a lot like an avalanche in a way, right? There are only so many things that can happen within a constrained space of possibility, right? You stay in one pattern for long enough, you get bored of it. You stay in one pattern for long enough in the same place, something about that place changes that makes so your old pattern has to change. That restaurant closes, for example. How does that impact your future possibility space when that happens, or a system's future possibility space when that happens, right? What happens to a system when it runs out of moves to make on the current plateau? What does it do? Well, it lifts, I guess, or it dies. But anything that persists lifts.
It's building muscle and momentum.
That's one way to think about it. Yeah. You can also think about it in the very literal sense of avalanche, right? Like if you want to add one more snowflake to that mountainside, then the whole hill has to change shape.
Fortunately.
Right. So you add enough snow, avalanche guaranteed. But after the avalanche, more snow can accumulate without a major reorganization of the whole surface.
Yeah.
So
it's identifying a generative expansion through an ordering form. It's ordering what we perceive as chaos.
It's a change of topology that permits more events to occur in a synchronized space, like in a system that already exists in one way. For it to continue into the future, it has to change. And there are lots of different metaphors that work, which is a cool thing, because like that metaphor channel, our ability to make metaphors is, for example, one of the ways that human beings lift using language.
It's acknowledging that most finite systems that we obviously live within, because we're stuck in the parameters of space and time, are never going to be perfect unless there's a balance in the extension of what we can understand, which good luck with that, the infinite being of the universe. So you're trying to extend to that balance through the finite by expanding into the infinite.
You nailed it.
To your
The imperfect coupling between closure pressure and continuation pressure is what creates the present. And that present persists because it never closes perfectly in integer space. It balances in log space, but there's always this residual, this little bit of continuation pressure that says, no, the system keeps going, even though this stability event just happened, even though we're on a new plateau after that avalanche.
This reminds me of Lysander Spooner's work, the deist reply, the alleged supernatural of sorry, it's been a little while since I've looked this up. The alleged supernaturality of God or something like that, and he talks about this. No matter how much we make progress, there's more things that open up that we just don't understand, and we'll never be able to close that gap. Let me find the name of that title now that I'm thinking about it, because it's going to bug me if I don't have it.
That's another way and that's the cool thing about this pattern, right? You can see this pattern across everything from the way people react when bad things happen, to the way that hillsides slide when you add too many snowflakes, to the way that orbits change when satellites collide. Like, the whole pattern is a fundamental pattern. Right? And the fact that it seems to fit everything is not a coincidence.
Yeah. The deist reply to the alleged supernatural evidence of Christianity. That's what it's called.
Yeah. Well, I mean, and that's the thing about the one innovation chronotopology made in set theory, and we haven't really talked about this one yet, and this is like deep chronotopology. Like, I haven't written papers on this because there are no building blocks yet in place to connect them to, right? So I haven't written extensively about this concept in set theory that I call metaparity, which is, like, if you imagine set theory as sets of commensurable things that are alike, you have odd numbers and even numbers as two separate sets, right? But nobody has, to this point, besides chronoscience, said, okay, odd even metaparity is itself a set. You can stick odd numbers once they are a set and even numbers once they are set in the same set and say that they balance, right? They become part of the same set because they are only definable in relationship to one another. And that balance is the finite, the infinite as a countable maximum quantity of everything that we don't know versus the infinite as an uncountable, unlimited thing. They balance at that point. Literally, the pressure between continuation and closure, the way that doesn't quite perfectly math except in log space, is exactly where you find, at least this is my conception of it, a spark of divinity. This is where the n finite and the infinite meet.
I mean, it's pretty wild stuff.
Continuation pressure is multiplicative and in that respect, completely ungraspably infinite, and closure pressure is n finite, right? It takes that infinite multiplication and says, nope, there's only so many things that can happen at once, and forces that balance.
Yeah. Lisa brings up a good point. I'm gonna unravel it into a different scenario, though. It's not that it's actually us. We're tricking ourselves into our pride, and that is one reason why we allow ourselves to be co-opted by other individuals, into a hierarchical scheme of where people believe that they are more superior and are the shepherds of the flock, which is inevitably not the case. And we're missing a piece on how we contrive our energy to this universe, because we stand in space and time. We forget that we are beings that are effectively outside of space and time. At least our soul, are the essence of our flesh bodies, are of a realm that is of outside space and time, of the eternal. And so, like, we have to attain towards that aspect. And I'm going, I'll go into like a Carmelite philosophy at this point. um, we have to learn how to contend to ourselves and to dying to ourselves and acknowledging that we are of this world, but we are not necessarily of this world. So we're
Right.
just sojourners of this life, wandering through to a promised land that we have no conceptualized identity for, because our brains are trapped in the space and time. So
Right.
we
Well, our
think on
brains
the
are
level of
physically
physical.
bounded. Our brains are physically
So
bounded, but they're a lot more
mhm,
like tuners in a radio broadcast of you
mhm,
than they are like the thing that makes you. It isn't the shape of your brain that carries the you part into existence. It's the shape of your brain that tunes into uh, a pattern that is you distinctly.
mhm,
Recreate that pattern again exactly, and there's no difference between this body that has the tuner that points to Greg and any other system that might do the same thing in the future, right? Like, I'm dead
mhm.
someday. You reconstruct it exactly. It's not a different person.
No.
We are ultimately unique unto ourselves as individuals, and
Mhm,
that's true across time. You don't die and then another one just like you eventually shows up. If another
mm,
one just like you eventually shows up, it means you're back.
mhm,
All right.
mhm,
Well, just to touch base with what I was talking about earlier, I'm not trying to be disrespectful to Christianity or anything. I was just referencing that because I remember reading about that back 2015, 2016. But that book is from 1836. This stuff that has been talked about for a long time, and the stuff that they're not going to teach you in school is stuff like this. Is that
Yeah.
you're gonna have more opportunities to make serious advancements if you get into stuff like this versus
Yeah.
just the mainstream stuff that they talk about on the news,
Well,
traditional
one of
news.
the more interesting aspects of discovering this pressure system with the help of chatbots, like, people will probably look at this and think, clearly Greg is just good at using AI, and that's all. Um, but if anyone ever says like you didn't do any real physics, the AI did it. Like, if OpenAI tries to come take credit for this someday, which they probably
Yeah.
will, the thing that I will be telling them is go back and look at the log history of all of those chats, because I had to fucking fight ChatGPT to do this math early on. It wouldn't even
mhm,
consider trying before. To this day, it still has trouble accepting the idea of counter local pressure from closure as a thing that is an actual force in the universe, as opposed to just a shadow tendency of continuation pressure. But the math won't math if you think of it like that. The
Well,
fact that there is
the
a global counter pressure that affects all localities simultaneously is remarkable, and I think probably what Zach noticed when he was
It's
talking.
well,
it speaking of the math doesn't math, I mean, the math doesn't math between 1933 and 1945. Specifically 1942 to 1945. The
Yeah,
math
the
doesn't math.
the different AI systems really are encoded, wired to be more of a novelty and being in that ballpark that they're designed to sell you. And so they're not going to give you the exact answer that you want. You have to really work for it to actually nail things down. You
yeah.
know,
Mm.
Yeah.
Brain
Also, by the
equals
way,
antenna equals resonance equals frequency. What Lisa just described is why prayer is real and prayer works. Like, peep this. I'm actually starting to do the liturgy of the hours the last couple days. Actually, Andrew, we did it yesterday. Thank you for that, in the morning. And the liturgy of the hours is divine. It really is. The way that you actually set yourself into that presence, you're if you truly fall into a sense of real prayer and let your mind not wander away and set yourself into a tone, then you are tapping into a resonance frequency of the
yeah,
divine.
yeah,
So
It shapes your future just as it shapes everybody else's who is influenced by it, right? Because thanks to the counter local pressure, a future in which someone who said a prayer of goodwill towards a person that they care about, or a situation that they want better resolved, and that person continues into the future, it adds weight to future branches where that prayer is answered. It actually can't help itself but reform the direction reality pushes when you decide to pray, because that decision actually has continuation, meaningful cost, right? You're spending energy to put that into a concept you can distinguish, and then you are ritualizing it, synchronizing with it in a way. Human beings, just like all agents, only interact with the world by synchronizing to it. If we're not synchronized to it, we call it out of phase. It's not even visible, if it's even there at all. It's not even possible to know. It appears as if, mathematically speaking, it was never there to begin with if it can't be synchronized to. But that's an experimental result that continues to show itself and will continue to show itself as long as people are doing experiments against it. But
if you're not synchronizing to reality for what it truly is, then you're going to live inside of what is being made for you. It's almost like the movie The Matrix. Like you're not synchronized to it, you're connected to a reality that someone made. And so I think that's what we're living in.
Minor correction, Zach. We don't live inside of time and space that's synchronized. We actually make the synchronization of time and space happen. We emit coherent time. Brains do. And they tie all the things that we observe into that continuation manifold. We make an observation, synchronized to it. We continue, therefore, the place has more literal reality to it, not because it was any less real before you were there, but because you enrich it with the choices that you make, and you direct the possible futures of a space because you inhabit it, right? That isn't a coincidence of living inside of a universe that was static and existent before you arrived at it, right? That is because of the choices you make while you live in it, and those choices influence its future. So really, it's more like we make the reality we live in, and if you can see
that's what I'm saying. Like what I'm meaning is like our brains are connected to see patterns, and that's how we get our perception. But when we're living outside of what we should be astute towards and acknowledging the choices that we make, etc., we accept the perception that we're making in our own thought process to what is being evaluated outside from other outside influences. We're focusing too much on the outside influences rather than eternalizing and understanding that there's more. We're actually just grabbing, like, we live in a consumerist, corporatized structure of society. It's pretty much just like you see an advertisement, it's all algorithmic, it's all the distinguish of the patterns are being made for you rather than you yourself allowing your brain to distinguish that pattern on its own.
Right.
It's just
once you're inside it, it's a long plateau with high walls that are hard to jump over, because once you're into the pattern of that consumerist culture, it continues, but it doesn't change. It doesn't change your future. Now, it does change your future in one way, because what you're doing when you're doing that is passively ignoring or actively ignoring the passive decay of possible futures, right? The system by itself would run down and wind down were it not for agents emerging in the system. That is why life and humanity are inevitable mathematical requirements of, well, not necessarily specifically humanity, but we exist. So specifically humanity. That's why the universe needs agents. That's why it needs people. That's why it needs souls, because without that, the system itself would collapse. We actually push multiplicative continuation and pressure ourselves, which suggests to me that if you wanted to point at the math and say there's the finger of God, right? that math, the math of closure pressure is the math of the divine, the counter local, the thing that allows for lift when when local possibilities are completely exhausted. It makes it so that an infinite thing can exist finitely. It's remarkable.
Mhm. Whereas society, for how it's become as of late, has it's extinguished that idea within us all. In my opinion, I think we've forgotten that edge of our multiplicity of our consciousness, um, living out our physical lives, because we're not thinking deeply. We're not creative in our own mind. We're not allowing our imagination to take place, and we're
Yeah.
not allowing our brain patterns to kind of manifest in our perception. We're just kind of just tunnel vision,
We have a
rat
hard
race,
time
rat
once we're
race.
used to it of
Yeah.
choosing divergent paths.
Mhm.
And in the culture we're locked into, a divergent path is salvation, right?
Mhm.
We all have to learn to be able to diverge and then do it.
Mhm.
That's the tough part. Anyway, let's
Yeah.
continue the video. That was a good segue.
All right. Yeah, sure.
Coordination constant remains stable, and headroom may increase or decrease. That last part matters, because a plateau can look stable while secretly becoming fragile. The apparent quiet of the plateau is not enough to tell you whether the regime is healthy. You also need to know what is happening to headroom. That is the hidden variable that decides whether the plateau is robust or nearing failure. Part 9. Residual accumulation. The paper then sharpens the role of residual imbalance. Small residuals can be absorbed locally. Large residuals cannot. Once they become large enough, they induce instability. This is another deep result, because it means not every mismatch matters equally. Some mismatch is just the normal breathing of a live regime, but accumulated mismatch is different. It changes the phase of the regime itself. So the paper gives you a way to think about hidden tension, not as abstract stress, but as closure imbalance that can either be locally metabolized or not. Part 10. Instability. Now the paper gives the instability condition. Headroom goes to 0. Continuation width stops increasing. That is the danger point. Not just because growth has paused, but because the system has run out of room to correct itself locally. This is where the plateau ceases to be stable persistence and becomes a precondition for transition. That transition is what the paper calls avalanche. But here is the crucial point. The avalanche is not treated as meaningless noise. It is not random failure. It is lawful. Part 11. Avalanche as lift. This is one of the strongest corrections in the paper. Avalanche is reinterpreted as lift. That means what appears as burst, rupture, or collapse from one level is actually a regime transition from another. structure reorganizes globally. New degrees of freedom appear. Continuation width increases. This is a huge conceptual shift. The paper is not saying avalanches are pleasant. It is not saying all collapse is secretly good. It is saying that avalanche statistics are not just destruction statistics. They are the visible distribution of plateau failures and reorganization magnitudes. That is a much deeper reading. Burst is not the opposite of order. Burst is what happens when one closure-stable regime exhausts itself and another begins to form.
This is a good place to pause because there are a lot of really great concrete examples of this. Solar cycles. People think of the active periods versus the dormant periods completely backwards. This is actually pretty fun. There's no such thing as a dormant period, right? There is a stable plateau period, and then once that stable plateau exhausts its current possibility space, once its futures are narrowed enough, then it becomes unstable and you start seeing solar storms. And then it enters what they call another dormant period, which is actually a brand new active period within a new stability regime. The same thing is true of magnetic pole excursions, like when people talk about the poles flipping. Geomagnetic excursions follow the same pattern. So what you're really seeing when you see a period of high solar activity is the end of an old active regime and the beginning of a new one, as opposed to an active regime kicking in followed by an inactive one. The most activity actually happens right after the visible outward signs of solar chaos, right? Solar storms. After those stop, the system inside the sun actually becomes a lot more active because it has a lot more future possibility after the reorganization. So that's one of the really interesting ways to think about this is like when you see something starting to fall apart, it isn't because the end of its activity period is about to be exhausted and it needs to rest. It's because it's running out of places things can go, and things are getting unstable because of that. And eventually it hits the edge of that stability boundary, reorganizes, and becomes stable again. That stability is not inactivity. It is the essence of continuation. So
that is pretty wild.
And I've actually mapped geomagnetic excursions with this math before, and it was able to naively spot the Carrington event without place it on a timeline in our history without any definitions being placed in there about geomagnetics at all. Just raw list ordering it, and set assembly was able to expose it. Yeah, we've got a storm here, guys. I might actually need to go batten down some hatches. Can you? I guess we've been out for about an hour and 15. Do we want to wrap up real quick?
Well, it's got 4 minutes left on it.
Let's do it. Let's just finish the 4 minutes. We good.
Yeah, let's go ahead and wrap up.
Part 12. Burst statistics. The paper notes that observed burst distributions often follow power law structure. Instead of reading that as mysterious criticality for its own sake, the paper reads it as the geometry of regime reconfiguration. That is elegant, because it means the burst sizes are not arbitrary decorations. They are carrying information about how plateau failure and lift actually work. Avalanche magnitude is therefore not just a dramatic output. It is a measure of how much reorganization the exhausted regime required. Part 13. Temporal alternation. The paper then compresses the whole story into a temporal rhythm. Plateau, then lift, then plateau again. Stable low fluctuation phase. Rapid reorganization phase. Stable low fluctuation phase. This is one of the most useful conceptual tools in the early canon, because it says the world should not be imagined as smoothly evolving forever at one scale. It alternates. Quiet and burst. Plateau and avalanche. Closure stable persistence and regime transition. That gives the theory a pulse. Part 14. Why this paper matters.
Or you can look at it like
Paper
this.
3 takes the static equilibrium insight of paper 2 and turns it into a full temporal structure. Now we know how regimes stabilize, where they stabilize, what their noise looks like, what happens when residuals accumulate, when headroom failure matters, and how apparent collapse can be reread as lawful lift. This is not a small move. It means chronotopology can now describe not just the shape of stable regimes, but the lawful rhythm of stability and reorganization.
Hey guys, I got to jump. My patio is
That
flying
is a
apart from
very
wind.
serious expansion of the
Okay.
flow.
All
You
right,
guys can
Greg.
finish up without me. We'll catch you all next time. I got to go stop stuff from blowing away.
Yeah.
Part
Go
15.
stop.
all good.
Go stop it.
Final compression.
Life
Continuation dynamics
and
are
patio
governed
flying
by
away.
a log space drift
matter
process.
more.
It's life.
Expansion acts multiplicatively. Closure acts logarithmically.
It's got a minute.
Equilibrium exists in log space. Plateaus hold while headroom remains. Residual imbalance accumulates. When headroom collapses, avalanche appears. Avalanche is lift. That is the paper, and it gives you one of the most important conceptual corrections in the series. Stabilization does not occur in raw, discrete size. It occurs in logarithmic continuation geometry. Shortest compression. Stable worlds drift in log space until they run out of room and jump. Hard compression. Avalanche is not noise. It is what lift looks like from inside a dying plateau. Margin line. Closure holds the regime together until the stored mismatch becomes the next regime's opening.
Stable regimes know when to adapt after an avalanche or after a fall. Know where the stableness is. The stabilization is that plateau. So the idea is adaptation, not complete like assimilation into an essence of something that you don't know or whatnot, but to adapt. So that's the moral of the story, is adaptation into the effect of what we don't understand.
It's a long march of history.
So, and as far as Greg, that must have been really serious. He didn't even log off. He didn't even disconnect. He had to book it. So hopefully everything's safe down there, and with some storms. So, but anything you'd like to add there, Elisha.
I mean, just that, like I said before, it's building momentum and strength. It's the bread and butter of this whole discussion. It's a long, arduous march.
Lisa says, great
Thank you,
show to
Lisa.
you, Andrew.
Thank you very much.
Andrew is the star of the show, as always.
I thought
So
it was
with that-
Bitcoin. Hey guys, thanks for watching. We'll see you next time. Okay.
We're not done yet. We're not done yet. So any final closing thoughts besides what you just said? Concerns, rebuts, plugs.
I mean, it does fall in line with this, the stuff like I was talking about before that I've read, just in passing, and I'm not a particular an expert in this. I don't know a lot about math. I mean, I can do math, but it really takes me a lot of effort to get into that kind of detail, like Greg has done. So I really am kind of speaking out of my element here.
Do you think that the logarithmic proves that the supernatural exists within the natural, or actually, I should say, without the natural?
Well,
Beyond
I
the
mean,
natural? That's why
I know that
supernatural is.
I was looking it up earlier. One second, see if I can find it. I was going to mention infrasound earlier, which is a different frequency the eye interprets, and if you get in that frequency, 19 hertz, you start seeing things that really could mess with your perception of reality, and that is something I just know a little bit about it, but
how do you? Yeah. Well, with that logic there, right there, Andrew, how do you explain a wafer cookie bleeding?
I can't explain that. I'm just saying it's there's things that scientists have been working on forever and ever, even now, that we just don't have an answer for. But it's that constant effort, that persistent push, like the video we watched today is that's what helps guide us and gives us, the potential to reach just such extensive, outrageous levels of knowledge in the from the universe.
It bleeds traumatically.
I'll take your word for it.
Where there has been medical explanations thinking that it's someone's heart tissue of someone who has gone through such traumatic event, like can you say it? A traumatic event. What would be a traumatic event?
PTSD, complex PTSD.
That would be psychological. I mean physical with the heart.
A heart attack?
Scourging.
Okay.
Being nailed to a piece of wood. Going through pain. Collapsing. That's what I'm talking about. The host bleeds, dude. I know losing a child, that's psychological. Yeah, that would be a psychological PTSD style trauma, and that's terrible. But I'm talking like physical, supernatural, miraculous aspects.
I can understand that. I'm sorry, that wasn't the first thing.
You have homework. You have homework, Andrew. You're gonna look up Eucharistic miracles.
I know the stigmata.
That's not a Eucharistic miracle, though it is miraculous.
I was just saying relative to what you were speaking about earlier.
But anyways, I think that's where we'll close for right now. If you enjoy this and want to make this our day job and become a shareholder, you can always become a shareholder and come help us set up a community over at the Patreon. The link is down below. But if you want to help us expand this and get more content and make this Andrew's day job, his full-time day job, a like and a subscribe and a bell ring is all you need to do. If you'd like to do more, you can. If you'd like to donate, that'd be awesome. But a like, a thumbs up, a subscribe, and a ring that bell. That's what matters. So other than that, I think that's it.
Well, enjoy Perfect Dark and Majora's Mask.
Oh, you just copyright.
I
You
know.
said the name, dude. Come on.
I know.
But
I'm sorry. What are you gonna do?
Yeah. But have a brilliant rest of your weekend, everybody, and we will see you next week for Silver Linings: The Legacy Ride.
Episode 21. Thanks for watching. Bye.